Hello all, welcome to part 28 of the Wireless LAN Security Mega Primer. So it's been a long break of around a month. I was traveling quite a lot and the schedule was very busy, because of which there could be no new videos. But that is going to change now, and I'm going to post a ton of video on wireless, finish off whatever is remaining, and then move on to more interesting topics. So let's get started. So we talked about WPA, WPA2 personal cracking using dictionary attacks, right? But we never really talked about how we can connect to a WPA, WPA2 network using a Linux-based system like Backtrack. And this is the focus of this video, simply because it is important that once you crack the key, you're able to log on to the network and do other activities, whatever they might be. So for that, WPA supplicant is the de facto tool. I understand that all Linuxes probably ship with your own GUI utility to connect to WPA and other networks, but I personally prefer WPA supplicant from a purely hacker's mentality. So WPA supplicant has tons of options. At the very same time, it is cross-platform. It can run on Windows, Linux, OS X, and probably even on FreeBSD if I remember well. And at the very same time, it allows you to better understand the process of connecting to WPA networks, which is very important from a hacker's perspective. Last, not the least, and in my opinion, the most important, is it's open source, which means, if you are a code hacker, you can actually do a lot of interesting things using this wonderful code base. So what are the different EAP methods which WPA supplicant supports? There are tons of them. I've just taken a screenshot from their website. It supports, I think, EAP SIM, MD5, TLS, PEEP, and a ton of other techniques, some of which we will look at when we go on to WPA Enterprise Security. The only interesting thing, which is a deviation from what you may have seen for IWconfig, is that WPA underscore supplicant utility requires a well-defined configuration file in which you can have one or more multiple allowed networks, right? So let's look at how to use this utility. Now, all of the information about WPA supplicant is very elaborately detailed out on their website. I would really recommend going to this site and probably going through the documentation. As far as going ahead and using WPA supplicant is concerned, to get started really quick, the best idea would be to download a couple of these sample configuration files. So as an example, this is how the WPA file would look like. I guess I'm not connected to the internet, but okay, I am, right? So WPA PSK TKIP, typically what you would have is the SSID of the network itself, then the key management, which is WPA PSK, protocol WPA, pairwise TKIP, group TKIP, and then finally the secret passphrase which can be used. There are other ways also to probably just go ahead and enter the shared key directly itself by using a couple of utilities, which I would encourage you to explore. I'll just use the configuration file directly for our demonstration. So what I've done is I've actually downloaded the configuration file and entered some credentials here. So the network which we will be looking at is security tube. Also notice I've changed the control interface. This typically comes in handy if you want to go ahead and do a lot of other interesting things like automation, etc., which we may take up later. And the passphrase which I've entered is ABCDEFGH. So now let me go to the access point and ensure that all of these have been applied. So we have a network called security tube, it's WPA personal, uses TKIP, and this seems to be the pre-shared key, which I'm hoping is ABCDEFGH, right? So now, how do we use WPA supplicant? So the first thing to ensure is of course that you have your network card up and running. So let's put WLAN 0 into a running mode. As always, this takes a little bit of more time. While this is running, in the next video we'll have a new competition based on a couple of things we are doing in this video, so you may want to pay close attention. Now the WPA supplicant utility has tons of options, right? The important ones include the driver to be used. In our case, we will typically use the WX or Linux wireless extensions, which is the generic Linux driver available. And along with that, we need to mention an interface, which in our case is WLAN 0, and finally the configuration file. So this is the minimum set of options you need to feed this tool. So let's go ahead and do this. The configuration file which we will use is the one we created locally, wpa-psk.conf, which we just saw. And then let's allow the tool to run. So the first thing it actually does, it's going to scan the air, figure out there is actually an access point which is there, and it's found out that security tube has the following MAC address or BSS ID as we know. It's associated, and finally the key negotiation has been completed, right? Because we had the correct passphrase. Now, what would have happened if we had the wrong passphrase as an example? Right, so probably instead of this, let's just add something else in the end, one extra, and then go through this whole process once again. And of course, I mean, there are no surprises. As expected, it should throw an error saying, well, it was not able to go through with the authentication. So it takes a bit of a time to probably, start the scanning. Many a times you may see a little error here saying that device unavailable or resource temporarily unavailable, but it eventually comes out of that. And if you notice, it actually says four-way handshake failed and pre-shared key may be incorrect. So WPA supplicant is going to keep retrying over and over again with a default retry period, till the time it's actually going to succeed. Anyway, let's quit this. So one of the interesting things which can actually also do with WPA supplicant is peer into the whole process a little bit more in-depth way by using the debug options. So one of the options which we will use here is to increase the debugging verbosity by using the -dd option. Also at the same time, typically the various keys which are derived and the passwords or passphrases which are being used are not printed. So let me kind of show you. Let me just use the -dd option so that we have a debug mode. And let's start this again. And if you notice, it will actually say, well, PSK passphrase, it's been removed, right? Basically, it does not want to show it in the output. So if you would want even all of this to be shown in the output, then you would have to go ahead and add an extra option which actually says include all the keys and other details. Now, if you want to figure out the amount of delays and a lot of other things which are happening, you could also use the -t option to print out the timestamps. Right? Now let's go ahead and run this once again. And if you notice, you have tons of details which are kind of just shooting off the screen. The important thing to notice here is that you have ABCDEFGH, which is the passphrase which we used, printed out in the clear, and then it actually tells you what it is doing step by step, right? And it's actually going from the disconnected to the scanning state, and I think very soon you would probably find something where it would say it's found the access point, right? Security tube, and from that point on it is trying to associate, and you notice it's probably printing out the capabilities and various things here. So it says going ahead and using TKIP, bunch of other parameters, state is from scanning to associating, and then we have the EPOL frames which have started going here, right? So from associating, it says it's gone to the four-way handshake, and these are the various messages. Message 1, four-way handshake, to finally the associated stage, right? And then you have a bunch of other dumps which you can go through. I guess various keys which have been derived are also being printed. And for example, here if you notice, it actually says installing PTK or the pairwise transient key to the driver, simply because you would want all the encryption decryption to happen at the driver level itself on the card, so that most of it is handled in hardware. And well, I mean, you can just kind of go overboard understanding each and every step and process with this huge amount of dump, right? And as you can say, finally it says authenticated, authentication completely succeeded, which means we are connected to the access point. Now, just like in a normal case, we could actually go ahead and get a DHCP address on the WLAN 0 interface if the access point we are connected to offers DHCP, which it does, or looks like it should. Let's see. Right, and we have gotten a DHCP address, which we had gotten previously as well, and now we could very easily go and hit the gateway, right, which is the access point. So this is how we can actually use the WPA supplicant utility to go ahead and connect to a WPA network on Linux, and then understand the entire process and do a variety of other things, right? So I would really encourage you to play around with this tool, and a lot of times many of this information can come in very, very handy. So for example, let's say you want to figure out what is the PTK which is finally installed. This would give you some information about what the PTK is. You could even tweak the code to do tons of other interesting things. Or you can even write interesting tools scripting over the code WPA supplicant utility, right? So let's now go back to our slides, and I guess this is all I had in mind for this video. The whole idea is to introduce you to WPA supplicant. I would advise you to try and create a WPA PSK as well as a WPA2 PSK configuration. Connect to the access point, ensure you enable debug, try to trace through what is happening at every step. Also try the same thing for web, right? So that's all for this video. Bring in your suggestions. I will take up the questions asked in the question and answers video in the coming week very soon. And as always, please leave your comments behind. I'm back. You're going to hear a lot more from me from now on, and hopefully all of you guys would be again participating and contributing on SecurityTube. That's all for this video. Thank you. Bye-bye.